Okay, so to conclude, to partially conclude the algebraic expressions part of the course, this is what I am going to do, right? I just want you to note that I changed the order in which I'm going to explain these sections because I'm trying to avoid as much confusion as possible with the section. We've already done evaluating of expressions. Now what I want to talk about is your odd and even and consecutive. What does it mean for numbers to be odd, even, and consecutive? Then I want to talk about products and factorization, give you a slight introduction into factorization. Then I want to talk about exponents. I will come back to restrictive type questions. So these sections, these two sections are not actually so much linked to expressions. They stand on their own, right? But you can see exactly what I mean by I'm starting to mesh the ideas together. So you will see exactly how they link, right? Then I'm going to come back to a topic called restrictive type questions. So this is a topic that is linked closely to algebraic expressions. These other two topics are linked to algebraic expressions, but not closely. They stand on their own. And then I will go to a topic called rational expressions so that you will fully understand all of the restrictive type questions that I will discuss. Right, so this is exactly, I just want you to note that I've changed the order. This is just to avoid confusion because you're at a grade 9 level, so all of this here, and because of the syllabus changing, you would need to understand these things a bit more closely. So what does it mean for a number to be odd, even, or consecutive? You see, for a number to be odd, so odd numbers, let's talk about odd numbers. Let's talk about some properties of odd, even, and consecutive numbers. Odd, even, consecutive. Odd numbers are like your 1, 3, 5, 7, 9, 11, so on. Odd numbers are 2, 4, 6, 8, 10. And now this is why I'm going to talk about it very closely, because we're going to start using these ideas when we talk about number patterns. You'll see there's certain questions where they talk about even and odd numbers. So what I want to teach you here is I want to give you a formula so that you'll understand how we can generate any odd number. To generate any odd number, but let me first start off with the odd numbers. You see, odd numbers are just basically 2 times some natural number. N is a natural number, right? It's 2 times some natural number. Can you see? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. To get your odd numbers, it's just 2 times some natural number plus or minus 1. That's how you get the odd numbers. Right, so it's just adding or subtracting 1 will give you your odd number. So it could be 2 times 1 plus 1 or 2 times 1 minus 1. So 2 times 1 is 2, plus 1 will give you 3, minus 1 will give you 1. Either way, the number is still odd. Right, so that's why you can have it in either of that variations. Right, so with consecutive numbers mean that the numbers lie one after the other. Okay, so now with consecutive numbers, this is the way you think of them, right? So consecutive numbers are numbers that follow each other in an order without any gap. Right, so you can think of like 1, 2, 3, 4, 5 are the first 5 natural numbers because they come directly after one another, right? They just come directly after one another. So exactly as I gave you a formula for odd and even numbers, you have to give you a formula for consecutive numbers. It's like n plus 1, it's some number, then another number that comes immediately after that number, and then another number that comes immediately after this number, so I'll have to add another one. And basically that'll give you n plus 2. That'll give you n plus 2. So that's exactly how we are going to use this formula. Yeah, so it'll be n plus 1, n plus 2. It's important to note that these numbers can be positive, negative, or 0, just as long as they are in this sequence. Meaning that just as long as they come one after the other, then they are what we call consecutive numbers. We can say that 2 is subsequent to 1, means it follows, it comes directly after 1. Right, and this is the reason why I said that this is more applicable for your number patterns module and more applicable to your word problems, because that's when you can actually apply them. But for now, just looking at this in isolation, there's not much that you can do with them. So that's the reason why I wrote a small word problem here. The sum of 3 consecutive integers is 60. What are those numbers? So the way you would do that, you would say, okay, it's some number plus a number that comes after that number plus another number that comes after that number must give you 60. And look here, see this n plus 2 exactly as I broke it down here. N plus 1 is a previous number to this number. I have to add another 1 to get to this number here. Do you understand? Right, so if I have to look at this, it'll be n plus n plus n is 3n. The reason I can add them is because the variable and the exponents are the same. So whenever you're dealing with variables, you need to check whether the terms are like before you actually add them. 1 plus 2 is 3 is equal to 60. Is equal to 60. Then 3n is equal to 57. And n is equal to 57 divided by 3, which is 19. So therefore, n is 19. N plus 1 is 20. And n plus 2 is 21. So 19, 20, and 21 are those three consecutive numbers. If I have to link it to everything that we have done thus far, see n is equal to 19. N plus 1 is equal to, if I'm evaluating this expression, is equal to 20. Just a bit more of a rigid approach. See, n plus 2, if I'm evaluating, it'll be 19 plus 2. Parenthesize whenever you substitute. Therefore, we have 21. So therefore, you have 19, 20, and 21. Right, so that's basically the idea that you need to remember here for consecutive numbers. So now we can basically partially conclude the topic of algebraic expressions, and then we can, at the end of the term or at the end of the sections, then we can start coming back to algebraic expressions. And I hope you can see that now we are starting to mesh the ideas. Right, it's all of the time these ideas are just taught as single sections. That's why you cannot fully understand them. And I cannot explain products fully, I cannot explain exponents fully, I cannot explain fractions fully, because when you start merging all of the ideas together, then you can get a full outlook on these topics on their own. Right? So you just need to start looking at maths from this perspective. And this is why I keep stressing the point that we have to look at them from a term basis. Right? At the end of term 1, you will be able to fully solve all of these problems. Right? Because when you link them together, there's so many different varieties to the question. Like, see, products and factorization, when I teach them, I'm going to teach them so simply to you, right? Like, you would trust me, you would never see the way we are going to teach it. You will never see it in any other book or video or YouTube video teacher or tutor teaching it the way that we are going to teach it. But the reason we are going to do that is because factorization is so vast. I'm going to teach it so simply to you because its applications are so vast. So you need to understand it thoroughly. And trust me, it's not going to get simpler than the way I'm going to show you in the upcoming video. So you need to understand this thoroughly. Please, because trust me, it's a very confusing section if it's not taught the way that I'm going to show you. So you have to understand this fully. Okay, so that basically partially concludes algebraic expressions. Let's move on to products and factorization in the next video.